Today, I'm going to show you how to do baked lighting in Aframe. This is going to involve showing you some stuff about how to bake lighting in 3D programs like Maya. You can probably transfer this to Blender. I'm just not sure what the technique for Blender is. Or you can use some other programs. There's lots of programs out there to bake lighting. So let's talk about what baked lighting is. What we have when we do the typical A-frame scene, let me just open one. Actually, yeah, we'll do this one from one of my other videos. So this lighting is all real-time, which means our shadows get cast. They're kind of rough because of the way the shadow mapping is done in the scene. And they also have this issue of clipping below the plane of collision, which means you're going to have these little highlighted lines. Just to show you what it would look like without clipping, so I've gone into the A-frame inspector. If you turn these lights off, or not without clipping, but if you turn the lights off so that we take all the real-time lighting out of this, we're still left with some lit objects, right? Because this sky background is set to render using a flat color. There's no lighting applied to that. That's why it doesn't have any shading. And then these models each have, if they show up, they have a reflection map applied to it, where the reflection map actually takes over a little bit of the lighting because it's providing the lighting to the object, let's say, based on how reflective the object is, the roughness and the metallicity. So you can see, each one of these objects has a slightly different setup. Well, now I've gone in. Let me turn on the lighting real quick. So if we turn off the lighting again, yeah, so you can see this particular model is getting its reflection map from not the spherical environment map, but it doesn't have an environment map applied. It's calculating it on the fly using the camera cube environment here. So when I turned it off, it didn't update, so I'd have to go render the scene. Now it pops, and you can see there's a little bit of reflection on it, but for the most part the rough areas are dark and only the metallic areas or the reflective areas are going to show through. So that's real-time lighting. The other thing to consider on that is that when the more lights I have in the scene, the more, especially if they're casting shadows, the more I have to render in terms of the draw calls in the 3D, in the WebGL. So more lighting means it's going to slow the render frames down. So what I want to show you is what if we could bake this lighting? Oh, something else to consider about real-time lighting is that there is no, well, there are equations that will do, like Unity will do this, but there's no global illumination. So if I actually don't have some sort of ambient light in the scene, the lighting's really harsh, it's dark. There's no bounce lighting in this scene because it's too complicated to calculate. So in order to create fill lighting or bounce lighting on these objects to make it look somewhat more real world, you have to actually put in something like a hemisphere light where you get like a ground and a color from the sky and it starts to light it a little more accurately, or even just an ambient light, which is going to be kind of a flatter overall lighting. In this case, I'm using this hemisphere light, which has a sky color and a ground darkness, and sort of approximates bounce lighting, but it's not great because there's no fall off and things like that and you don't get any bounce lighting from the color. Like these two objects with this gold sphere and the light bouncing around in the scene, this gold sphere should be putting a bunch of yellowish light onto this the side facing it on this object, and then vice versa, the same for the gold sphere. Although the gold sphere is so reflective, it wouldn't take much bounce lighting. And the same things for these statues. And this seems really picky, but this is how you start to get photorealistic results, and it doesn't have to be intensive if you bake the lighting. So if you bake lighting, we won't need these lights. We can turn off lights, or we can have like one light, which will allow us to capture bump maps and certain details that we're doing in the mapping, not have to have shadows, and turn off everything else and just let it calculate, and then it'll just render that one light without any shadows. It'll be much more efficient. So I've gone and set up a scene to do just that here in Maya, and all it is it's just a test scene where we have a linear light casting shadows, and these little point lights that are colored casting red and blue in the scene, but also casting shadows. So what that renders like, if I run it in the Maya Arnold renderer, we'll just start a preview. As you see, this is what bounce lighting looks like. It's going to be a little bit slow because I'm capturing this video at the same time, but the blending of the lighting is much more photorealistic. You get ambient occlusion, you get soft lighting in the shadows, you get bounce lighting, especially on the back side of the sphere, where you get like the ground and the cubes here reflecting light back at the sphere. That's called global illumination. And this gives you a much more realistic type of lighting. So it's slowly refining this as it goes. It's going to take a while, but in order to stop it, I'm just going to stop the scene that was restarting it. Now let me stop it, turn this off. So we've got this scene set up. I've already gone and captured these textures for each one of the UV maps for each object, and I'll just show you what that looks like with baked lighting in Aframe. So if I open that with my Firefox viewer, here I am in Aframe with the baked lighting slapped onto each object. Notice that I don't get the clipping from the shadows, right? Because the shadows are actually cast onto the textures that I'm putting there, so there's no light clipping through the bottom of the object. We'll talk about some of the issues. You notice that this has lighting on it. Let me just show you real quick. This object has a light map applied. You're not going to see it here because the light map isn't turned on in A-frame by default, but I've gone then and went ahead and applied metalness maps and things like that to give it an extra texture, but it actually still has the lighting, the light map applied, because I've created this light map component up here. And on top of that, I've gone and created this cube map component, which will then also capture these objects that also have light maps reflected in the environment, so it just starts to look really realistic. This is an example of one of the light maps. I just took this cube and applied the light map to it. There's no extra anything, there's nothing else. This is what a light map would look like, but I've gone and applied it to the cube and just added that to the scene, so it's not actually baked into these other light maps. So just to show you, if I turn off the one light in the scene, you can see I've still got my lighting baked. It changes the way the sphere renders, because I'm losing, without a light, I'm losing my bump map and my diffuse and metal map. I still have my reflection map, but you can see it sort of flattens the look. So you need a little bit of light if you're going to have any kind of mapping on an object. You're going to need a tiny amount of light. In this case, I've got the light cranked down to like a 0.320 intensity, so it doesn't, because if I do the standard 1, it's gonna, the combination of the lighting and the light map are going to wash the scene out, right? And then you get like accurate lighting here, but well, actually you're getting extra lighting on this object too because of the light map. So I just sort of crank that down to like 0.35. so that I get my light map looking the way it should look, and then I also can have my specular and bump from the directional light. Then obviously I need to take this directional light and kind of position it so that it's relative to the way the shadows are casting for the main light in the scene. You can also see that I'm getting because I'm using these baked lighting, I don't even have my point lights in here. I could add them if I wanted to, but then it kind of defeats the purpose of having the baked lighting. Although I could, lose the shadow casting. But I could put the point lights in and get more realism in terms of the way the specularity hits the metal maps. But I don't really need that at this point because the baked lighting sort of works for it. Okay, so this is what we're looking for in terms of what a baked lighting scene can do. Now, how do we actually get this to work? So the issue with, let me close this down for now. We'll go back to Maya. We've got these objects that we've set up, and if you're working in a 3D program, you should understand how UV mapping works. Basically, UV mapping is taking this object and sort of unwrapping it, and this will tell you how the textures wrap onto the object. So I just selected this face, and then there's the front face. I don't know if you can see that because of the color, but maybe on this one. Yeah, so there's that face. So each one of these objects is going to have its own individual UV set. Sorry. It's going to have its own individual UV set. And right now, none of these, in terms of have a texture baked to them. I'm just the light rig is set up for rendering. And then if I want to actually render this, I just would select, at least in Maya, I select each object, and then going into Arnold and Utilities, I can bake selected geometry or bake render selection to texture. And that's going to render a square texture of this object's lighting using these UV maps. And then the same thing for each one of these. So I can kind of bake all of my textures into the object. Okay. Now, these UV maps, if you look at the UV sets, there's only one UV map per object. So if your UV set per object. And what you need, the way ambient occlusion and light maps are set up in Three.js and Aframe, is that it needs a second UV set to apply for the light map to actually show up, or the ambient occlusion to actually show up. So what I've done, because I've tried this a couple of ways, I haven't figured out a way to get it to work by going and setting a different UV set, because the light map is going to use whatever you've set the UVs to be for the second UV set. Okay, so in this case, I don't have a second UV set. I'm actually adding the UV set in A-frame because I'm just copying the UVs that are on the object and duplicating them. So in that case, I'm getting a clone of the original of each object's UV set, which is predictable. I can take this and have a UV set layout, render that, bake the texture, and then just go into A-frame and duplicate all the UV sets on each object and apply the light map, and it'll work. It'd be nice, and theoretically you should be able to do this, where you can take and create optimized UV sets. So I could theoretically create and combine all of these objects together and lay out their UVs so that they all fit within this square, bake a light map for that, and then use that as the second UV set for each one of these, and then have these original UV sets, which can be laid out totally differently, and create tileable textures like bricks or whatever, because what you'll get is a lot of the times you'll have repeatable patterns across your surface, like a wall or a floor where you have a floor tile, and you'll just want to use a small texture for that tiles and looks good. But then if you do that and you bake the lighting for a small texture, it's not going to be very crisp or sharp. So the advantage of light mapping is that you can have tileable textures for your first UV set for all of your maps, and then use a second UV set, which can be laid out totally differently and optimized for just the lighting on the object. And this is the same in Unity as well. Unity actually bakes and creates UV maps on the fly so that you get global illumination and baked lighting in a separate UV set for the entire scene. Multiple UV maps are created and generated. And there's actually a project that tries to do something similar to that for Three.js and Aframe, but it's not been updated in a while, so I'm not going to show that at this point. Anyway, a lot of technical terms. But the gist is we're taking the lighting in this Maya scene, getting a much better capture of it than Aframe can generate real time, because we're going to be getting bounce lighting, global illumination, shadows, everything all at once. And then transferring that, I'm going to show you what these individual maps look like. If we go into probably objects and lighting. So the other thing is, like, Arnold will render out these EXR files, which are actually even higher quality, and they're more like HDR images for the scene. But here's our light map for our surface plane. So you can see, like, the reason we're not getting this light clipping is we're actually getting the shadows where the cube sits on it baked into the object. But you can tell, this is much higher quality lighting than you're going to get in a real-time render. The same, this is one of the cubes, this is the sphere, here's another one of the cubes, and then this is, I've actually gone and created an occlusion map. Now we'll get into why I did that. But this is an occlusion map that I can also apply to the plane in order to fix an issue that you'll get when you combine hybrid lighting on the object. So when I say hybrid lighting, I mean by having that extra light that allows me to put other maps. Let me open that up again. Light map, here we go. So open with Firefox. So by hybrid lighting, I mean because I have a light in this scene that's actually giving me the ability to see the bump maps and stuff that I talked about earlier. So you can see the bump map and the specular reflection, the same thing on the floor here. But notice how it's occluded. When I get into the shadow, I shouldn't be able to see that speck because it's being occluded by the object, right? Which is what's causing the shadow to cast. So that's where the specularity comes through and doesn't show in the shadows. And that's there because I'm using that occlusion map. Let me open up the plane. I've gone in, so I've got my light map geometry here, and I believe, I'm using the occlusion map as a roughness map here, the one that I baked. I'm just applying a roughness map, this, to the plane so that light, when it hits these dark areas, will be or when it's in the lighter areas, it won't be as specular. It's going to get more diffuse. So it's still there, but it's getting diffuse. So that's kind of simulating the bounce lighting that we're getting because these shadows aren't completely dark. And then on these darker areas, it's going to be less diffuse and more shiny, and that's why the specular shows up. So if I take that off and then render this, it's got to reset the scene. Actually, let me just turn it off in the code. If I open this scene and my plane, let's see. Just got to figure out which one's the plane here. Yeah, here's the roughness map right here for the plane. So if I just take that out, actually if I just take both of these settings off of the material, I think. Actually no, the other ones are set to a roughness of 1, 2, so that's fine. And save that. Now I'm going to open that and show you what the difference looks like. And this is why we have the ambient occlusion map. So actually, because I've got the roughness turned up, there is no specularity, but assume that I'll show you. Take the plane and because I left the roughness in there. Let's assume that I want it to be a shiny floor, or I want it to have shininess where the light should hit it by cranking the roughness down a little bit. Okay, go back to my scene. Notice that I'm getting specular highlights now where the shadows are, which makes no sense. It's like these objects on the plane aren't including the specularity of the floor, right? And that's where that occlusion map comes in. And all it is just putting a roughness map on the floor that says, wherever I want the floor to be shiny, it should be dark, and wherever I want the floor to be really rough or occluded, like shadows, then I'm going to have it be lighter. Okay. Another way to simulate that same effect, let me just go back into this and add my roughness map back in. Another way to simulate the effect is to actually turn on shadow casting for the lights. And you're like, wait, I thought we baked shadows. But just to show you that it can work that way as well, and it can actually then work for lights that you didn't, or objects that you didn't bake into the scene. It'll work, but then we're back with this occlusion issue, or the clipping issue of the light, because we've turned. But you can see the specularity is getting occluded because I'm also casting these shadows on top of the shadows that I had. And again, it also works for this new object that I've put in there. But like I said, I get some issues with the light showing through because of the specular and the clipping. So the occlusion map isn't helping here. So let's look at why you do one versus the other. So this is a quick and easy way to do it if you don't want to have to render the occlusion map, which you could basically do just by baking a shadow map on your plane or your objects in general. We're at 45.73 frames per second, which is pretty good performance. But let's see what it looks like without the shadows cast. We're at 57.96, and actually this goes up to 70 something when I'm not recording video on top. So you can see, because I'm not casting any shadows, I'm not getting any shadows from objects that I haven't baked into the scene, right? So this cube that I've stuck in there doesn't cast a shadow, but the occlusion map does a really good job of blocking out the light, and I'm not getting any clipping in this. So you just get better lighting this way. And it's one more way to add realism to your scene. Plus, if you have like a really complex scene, assuming you can bake the lighting and you can get them into a low, the texture count low enough, you're going to get much better performance frame-wise for your rendering, and more realism as well. Okay, so let's see. How did I go about creating this roughness, or this light map component? So if we go into, I've got this component. I'm going to link to this to it in the GitHub. It's on the same GitHub, in the components GitHub that I had for my previous video where I talked about reflection maps, and I created that real-time cube map, cube camera reflection component. But I've got this light map geometry component, and all it wants is a path to the actual light map, and then I give it a RGB format for the texture. So I'm creating a new texture loader in the init, and then I apply this light map, I apply light map function. I'm just binding it to the component, so that once everything's loaded, then it will get the object, give me the texture for the light map, and then traverse the mesh, and any mesh that is a buffer geometry which is pretty much any mesh in Three.js, I create a second UV set. Remember I told you lightmaps and ambient occlusion maps require a second UV set. So even though ambient occlusion maps are allowed in A-frame, if you don't have a second UV set, you can apply a map to it and it won't work. It won't show up. So by doing this, basically saying clone the UV that we already have on this object and make a second UV set, all of a sudden you get light maps and you can apply them, and you can also apply ambient occlusion maps. And then I just apply the light map and say material needs update. So that's how you create this light mapper. So pretty much any kind of map or any kind of function that isn't enabled in A-frame, you can use the same type of component setup to parse through the object and activate that map on the object, or inject another map into the object that's besides the one that's already there using this type of setup. So that's pretty much it for this. What else could you use? Oh, well, you could also, another thing you could do is if you didn't want to have reflection mapping and there wasn't any objects moving in your scene, the way I'm capturing this map right now is I'm just using a kind of a ceramic white material on the object with no reflectivity. And very little eccentricity. And this, this is something you can tweak for how you're going to bake your light maps. But basically, I'm just rendering these in a kind of like matte white texture, so that I'm only capturing the light, because all I care about is the light information for the light map. But if I wanted to bake the reflection and everything else in as well, I could just crank up this reflectivity, and that would then suddenly show up in the light maps baked onto the texture. Of course, obviously that'll only matter if you don't want to bake them or have objects moving in your scene in real time that you're going to want to be capturing in the reflection map. Or if you don't want to, you might only bake lighting on some objects. You might put other objects in there and have them either not cast shadows or cast them from a light, so that you can build a scene of parts or components without having to account for every condition. Because this can actually get pretty cumbersome in terms of setting up all of these objects later, so that you account for the entire scene and bake the lighting. You're going to have a lot of light map textures, and you have to go through and apply those using the component. So anyway, hopefully you found this useful. This is sort of out on the extreme in terms of trying to go for like ultimate render quality, but sometimes you just want some global illumination in your scene that you're not going to get from standard lights in A-frame. So hopefully you'll take a light map or take a look at the light mapping. Like I said in the previous video, if you want to test this stuff out, go to the Three.js. You're going to be able to see everything that's on the materials editor. If you go into that and you add, let's say, a plane. There's my old Athena model. So this plane, if we add that and we look at the material, you've got color map, which in A-frame is source map for some reason. The alpha map, which isn't enabled in A-frame, so you can actually make kind of a cookie cutter transparency control on this. You'd have to enable that. A bump map, which is similar to a normal map. I'm not even sure why they allow for both. But the normal map is usually the one that we'll use, so that's your detailed surface information. And then this displacement map. So this displacement map is another one that's pretty powerful. That'll actually allow you to add geometry to the object and distort it, like deform the object with more detail. But it's also very intensive, so I probably won't end up doing something about that. But you can look up displacement maps if you're interested. Here's our roughness and metal map. There's the environment map for reflections that we covered in the last video, and then here's the light map and the AO map. You also have this emissive map, so you can make this thing emit or appear to emit light in a pattern based on a texture. So let me open up my textures and find something really dark, probably, and it can be color too. Let's do this. It's the best pattern I see so far. Actually, yeah, this will look cool. And then enable that. And let's see. It's not emitting. It's not an emission setting. It doesn't appear. Let's try a colored map. Nope. So this may be a bug in the editor in terms of, or maybe it's the material format. So you also get, in the editor, you get all of these different types of formats. Mesh standard's the one that is the default for A-frame, but there's also this mesh physical, which you could try to translate over to A-frame. You'd have to create a component to do that, but you could do it. It's probably more costly, but that's this is another level of kind of realism you can add. It has similar maps to the standard format, but it's I guess by the name it's supposed to be more physically accurate or more physical based with less sort of shortcuts like the standard material might have. So if we go back to standard material, and let me just tone the clear cut. Wait, still on. Oh, the other thing is this mesh physical material actually has clear coat and clear coat roughness, which is similar like the kind of gloss you would get on a car. You could see that easier, and actually you could see that easier on a sphere. Play around with it though in here. The editor, you can download your own version from the source for Three.js, or but it's you can just go to the threejs.org/editor and then edit there, and it actually will remember. Like I was working on this, it'll actually remember the last scene setup that you had, as long as you don't wipe your memory, the browser memory, so you don't lose work if you accidentally close your browser or take a break for lunch. So anyway, these are all the different maps, and so you can play around with transparency. Now the thing is, you got to realize, you have to enable a lot of this stuff in A-frame in order to get it to show up in A-frame. You can obviously, if you don't want to deal with A-frame, you can also just play around in Three.js and then export this and load it in the standard Three.js format. But since this is a video about A-frame, it'll also go into A-frame. You just have to do a little work to get it there. And I highly recommend playing around with Three.js and looking at what it can actually do, and then trying to figure out ways to activate the things you need from that in A-frame using components or more advanced shaders. So anyway, hope you liked the video, and if you have any questions, just leave them in the comments.